Hello students, the next part is the Newton's formula for velocity of sound. We know that sound are the longitudinal waves and the speed of longitudinal wave in a medium depends upon the two factors, that is the volume elasticity of the medium and number 2 density of the medium. So velocity of sound in a medium depends upon the volume elasticity and density of medium. So on the basis of this, that the speed of sound in air in medium depends upon volume elasticity and density of the medium, Newton formulated a formula for speed of sound in a medium, and this formula is on the basis of this Newton formulated the relation as speed of sound v equal to square root of E upon rho, where E is the elasticity of that proper elasticity of the medium and rho is the density of the medium. What do you mean by here proper? Proper म्हणजे if the medium is solid, then we must consider the elasticity related with change in length, that is Young's modulus. And for if the medium is either liquid or gas, then we must consider the elasticity that is related with change in volume, that is volume elasticity. And here density rho is the density of the medium. So this is the formula, general formula for speed of sound given by the Newton. Now we will study the special case, that is Newton's formula for velocity of sound in air. Now you know that when the sound or the longitudinal wave travel through a medium, then in medium alternate compressions and rarefactions are formed. Newton assumed that the formation of compressions and rarefaction in a medium is a slow process. ह्याचा परिणाम काय होतो मग the heat which is developed at the compression gets sufficient time to pass away and therefore the temperature remains constant. Similarly, where the rarefaction is formed, the cooling takes place. But as it is a slow process, therefore heat is passed inward and therefore again the temperature remains constant. And the process in which the temperature remains constant is called as the isothermal process. Therefore, Newton assumed that during the propagation of sound wave through a medium, temperature remains constant and is a isothermal process. So Newton assumed that the propagation of sound in air is an isothermal process, that is temperature remains constant. Hence, the isothermal volume elasticity should be considered. The isothermal volume elasticity of air is equal to atmospheric pressure P, and therefore we take E equal to P, and therefore this equation 1 becomes V equal to square root of P upon rho, where P is the atmospheric pressure and rho is the density of air. Now the atmospheric pressure at normal temperature and pressure, that is NTP, is 1.01 into 10 raised to power 5 Newton per meter square, and the density of air at NTP is 1.293 kilogram per meter cube. So substitute this value of pressure P and density rho in this equation 2, and after simplifying here we get the speed of sound in air at normal temperature and pressure, that is NTP, is 279.3 meter per second. Thus, according to Newton's formula, velocity of sound in air at NTP is 279.9 meter per second. But at the same time, the number of experiments were performed to determine the speed of sound in air at NTP. And according to this experiment, the speed of sound in air at NTP is 332 meter per second. But the experimental value of the speed of sound in air at NTP is 332 meter per second. So this is the correct value, and this is the value given by the Newton's formula. That means the value of the speed of sound in air at NTP is much smaller than the experimental value. That means some correction is necessary. Newton formula does not give the correct value. आपलं काय लिहिता येईल मग, therefore the Newton's formula for velocity of sound in air does not give the correct value. आता ह्याचे करेक्शन आवश्यक आहे. सो लॅप्लेसेस गिव द करेक्शन फॉर द न्यूटन्स फॉर्म्युला. काय करेक्शन आहे बघू आपण या ठिकाणी. आता हे न्यूटन इथं सुरुवातीला जे अज्युम केलं होतं, दॅट फॉर्मेशन ऑफ compression and rarefaction is a slow process, This assumption itself is wrong. हे ऑब्झर्वेशनच काय हे चुकीचं आहे. कारण तुम्ही जर विचार घेतला, आपण जे ट्युनिंग फोर घेतला, मी तुम्हाला जो काल दाखवला होता, त्या ट्युनिंग फोरची सर्वसाधारणपणे फ्रिक्वेन्सी कमीत कमी म्हणलं तरी किती असते, 250 हर्ट्स. म्हणजे एका सेकंदामध्ये त्याचे 250 व्हायब्रेशन्स होतात. म्हणजे एका सेकंदामध्ये 250 कॉम्प्रेशन्स आणि 250 रेअरफॅक्शन तयार होतात पर सेकंद. दॅट मीन्स दिस इज नॉट ए स्लो प्रोसेस, बट दिस इज ए फास्ट प्रोसेस. दिस इज ए रॅपिड प्रोसेस. Now we'll see. The Newton's formula for velocity of sound in air is V equal to square root of atmospheric pressure upon density of air. हे आत्ताच आपण बघितले या ठिकाणी. Newton obtained above the formula by assuming that the formation of compression and rarefaction in a air here is a slow process. आत्ता सांगितल्याप्रमाणे, and that is a isothermal process. But the Laplace, it is a scientist, he is a scientist, तिने काय सांगितलं, he pointed out that the production किंवा formation of compression and rarefaction is not a slow process, but it is a fast process or rapid process. त्यामुळे काय होतं मग, thus the heat developed during the compression or the cooling take place at the rarefaction does not get sufficient time for dissipation. त्यामुळे हे फास्ट प्रोसेस असल्यामुळं जी काही हीट प्रोड्यूस होत असते किंवा डेव्हलप होत असते ॲट कॉम्प्रेशन, इट डज नॉट गेट सफिशियंट टाईम टू पास अवे, अँड देअर फोर द हीट रिमेन्स कॉन्स्टंट. अँड द प्रोसेस इन विच द हीट रिमेन्स कॉन्स्टंट इज कॉल्ड ॲज द ॲडिबॅटिक प्रोसेस. बघा परत मी येथे रीड करतो. लॅप्लेसेस पॉइंटेड आउट म्हणजे निदर्शन आणून देणे, द प्रोडक्शन ऑफ कॉम्प्रेशन अँड रेअरफॅक्शन इज नॉट ए स्लो प्रोसेस, बट इट इज ए रॅपिड प्रोसेस. Thus, the heat developed during the compression or cooling during the rarefaction does not get sufficient time for dissipation. Hence, heat remains constant and the process is adiabatic process. लक्षात घ्या, adiabatic process is a process in which the heat remains constant. Heat is neither given nor heat is taken. Heat remains constant. And the adiabatic volume elasticity of air is E equal to gamma times atmospheric pressure. P. What is gamma? Where P is the atmospheric pressure and gamma is the ratio of specific heat of air at constant pressure to the specific heat of air at constant volume. That is Cp upon Cv. And for air its value is 1.41. इथे दिले, where Cp is the specific heat of air at constant pressure and Cv is the specific heat of air at constant volume. And therefore, the Newton's formula becomes speed of sound in air V equal to gamma P upon rho. Original formula का होता E upon rho. Now substitute E equal to gamma P. So this is the formula. Now, by this formula, if we simplify, if you put gamma equal to 1.41, atmospheric pressure P equal to 1.01 into 10 raised to power 5 Newton per meter square and density as 1.29 kilogram per meter cube, and after simplifying we get the value which is very close to the experimental value, that is 332 meter per second. This formula gives the value of speed of sound in air at NTP which is very close to the experimental value. So this is the corrected formula. काय केला मग न्यूटनने, लॅप्लेसनं काय करेक्शन सांगितलं मग, that the formation of compression and rarefaction in air is not a slow process but it is a fast process, and hence instead of considering the isothermal volume elasticity we must consider the adiabatic volume elasticity, and this adiabatic volume elasticity is equal to gamma times P. And if you put these values we get the speed of air at NTP which is very close to the experimental value. So hereafter इथून पुढे आपण हाच फॉर्म्युला यूज करणार, that Laplace's formula, that is speed of sound in air is square root of gamma P upon rho. What is gamma? It is a ratio of specific heat of gas at constant pressure to the specific heat of air at constant volume. We will study next part in the next video. Thank you.